Hi everyone, and welcome to our channel. In this video, we're going to discuss electricity and circuits. We'll explore how electricity functions using a water system as an example, and we'll also learn how electricity is applied within a circuit using a circuit diagram. Electricity is a form of energy that can be harnessed and converted into heat, light, movement, and power. But before you begin your project, you should know some of the basics of electricity. Here we have current, which is measured in amps, and it is the rate at which charge is flowing. And in this figure, electricity will travel from the positive end of the battery through the resistor and light bulb and back into the battery on the negative end. Next, we have voltage, which is measured in volts and is the difference in potential energy between 2 points. The voltage source in this diagram is the battery. Current will flow from the positive terminal of the battery through the circuit and back to the battery through the negative terminal. Finally, we have resistance, which is measured in ohms, and it is the friction or opposition of current flow. Here, to avoid overpowering this light bulb, the amount of current flowing from the battery is controlled through resistance. Knowing the basics of current, voltage, and resistance will all help with the completion of your project. Now, we'll apply the same concepts you've just learned to a water system. Water flowing through a hose will naturally flow in one direction. And in this example, the hose diameter will affect the rate of flow. A wider hose will give more water, whereas a narrower hose will limit the amount of water flowing through your system. Similar to voltage, pressure is required for water to circulate through the hose. And in this example, voltage represents the force needed to push your water through. So if current is the rate of water flow and voltage is the pressure that pushes your water through the hose, then resistance is the sand or dirt inside the hose that slows down water flow. Therefore, the more dirt inside the hose, the slower the rate of flow, or the less dirt inside, the faster the rate of flow. Here, we'll apply current, voltage, and resistance to a circuit diagram. Circuit diagrams used by electricians and engineers are a pictorial way of showing how everything is connected together in your circuit. The lines or the wire in your diagram will act as the hose in which current will flow throughout your circuit. Similar to the water system, electrical current flowing in one direction is also known as direct current. The battery in your diagram will be activated when you create a closed circuit by flipping the switch on. This will cause voltage from the battery to force current through your circuit loop. We'll talk more about circuits later in the video, but just know the greater the voltage, the faster the current will move. And as voltage decreases, so will the current, like when a flashlight starts to dim when the batteries run down. And lastly, we have a resistor, which controls the amount of resistance in your circuit. And just like the water system, the higher the resistance or the more dirt, the lower the current flow. And the lower the resistance or the less dirt, the higher the current flow. As you progress with your project, you'll be seeing more and more circuit diagrams. Now we'll move on to circuits. You'll remember the ground and 5-volt pins from our previous breadboard tutorial. To complete a circuit, there must be an unbroken or closed path from the positive to the negative, which means for your prototype, electricity will flow from the 5-volt pin through your device to the ground. Electricity will always take the path of least resistance, so if you accidentally provide a path that is directly wired from the 5-volt to the ground, this will create a short circuit. In this situation, your wires and batteries will overheat. If this occurs, a safety protocol will be activated, causing the breadboard to shut down in order to prevent any further damage to your prototype. Now that you've become familiar with some of the basics, we're now going to jump into our first activity by powering an LED. Power, which is measured in watts, is the rate at which an electrical device converts energy from one form to another. For example, a 100-watt light bulb is much brighter than a 60-watt because the higher wattage converts more electrical energy into light. For this activity, you will need one breadboard, a 10K ohm resistor, one LED, and 2 male-to-male jumper cables. Take one jumper cable and connect the ground on the breadboard to the negative power rail on the breadboard. Next, take your LED and connect the cathode or the shorter leg to the negative power rail on the breadboard. Then take the anode or the longer leg and place it on the terminal strip. In the same row on the terminal strip, place one end of the 10K ohm resistor. The resistor will be used to regulate the current flow through your circuit. If too much current flow throws your LED, it will cause the LED to burn out. Take the other end of the resistor and place it in another row. Lastly, in the terminal strip of the resistor you just inserted, take your last jumper cable and connect the end of the resistor to the 5 volts on the breadboard. At this point, connect your breadboard to your computer using the USB connector. If your LED is lit, congratulations, you've successfully completed a circuit. However, if your LED doesn't light up, don't worry. Recheck your connections again using the diagram from this video. Thanks for watching, and please let us know if you have any questions in the comment section below, and be sure to check out our other videos on our First Nations Mesa channel.